Now, with the empirical rule, the previous assignment, empirical rule, we learned some percentages, right? We had to move a complete standard deviation. So we started at the mean. We had to move one standard deviation to the right or left, a second standard deviation. We had to move an entire standard deviation. But what if I don't move the entire standard deviation? What if I only move part of it? Chebyshev created a theorem, and the theorem we're going to be using for the Chebyshev rule is going to be that at least, they're going to give us the percentages. The formula I want to use is 1 minus 1 over k squared. Okay, 1 minus, and then the fraction 1 over k squared. So at least this percentages where k is going to be a number greater than 1, but not necessarily an integer. Remember, k is how many standard deviations do we use? Do we use a whole standard deviation? Do I use half a standard deviation? Do I use a 1.5 standard deviation? So that's why I say k is how many standard deviations I use, but it doesn't have to be a whole integer. Okay, so remember, arcade is going to be the difference. I'm going to compare some values. So the difference divided by standard deviation. Basically, how many standard deviations do I move? Okay, so let's take a look at here. A survey of local companies found that the mean amount of travel allowance for executives was 25 cents per mile. This is the mean. Now, the standard deviation was 0.02, so 2 cents. Using Chebyshev's theorem, find the minimum percentage of the data values that will fall between 20 cents and 30 cents. Okay, so the mean is $0.25. I know here it is 0.30, and then I know here is 0.20. If I was to go to the left, I go I go down, right? The difference is negative. If I was to go to the right, the difference is positive. Some of you might be wondering, I can tell the difference is 5 cents. From 25 cents to 20 is 5 cents. From 25 cents to 30 is 5 cents. So the difference is 5 cents. Now, this is how we're going to find our K. I'm going to find the difference, and the way I'm going to find this is going to be 0.30 minus 0.25. I'm just going to find this difference divided by my standard deviation, which is 0.02. So I find the difference divided by standard deviation. So how many standard deviation did I move? Now here, I'm going to type this on my calculator. I can type in a fraction. Use the calculator that I gave you guys on Canvas if you need to. So type in a fraction, 0.30 minus 0.25 over 0.02, and it gives me 2.5. So I'm going to move 2.5 standard deviations to each side. Okay, now here the question was not find K, the question was find the minimum percentage. So I'm going to use the formula that I gave you guys earlier. 1 minus 1 over K squared. That means I'm going to go 1 minus, here I'm going to have 2.5 squared. I'm going to type this on my calculator. Like I said, use the calculator I gave you guys on Canvas. It's pretty simple to use, so use that one. Watch, let me show you with you guys the calculator. This is easy to use, right? I'm just going to go 1 minus, I need to type in a fraction, so I go here. Then I have to go 1, click down, 2.5, and then here's my square. Right? That is what I wanted to type in. 1 minus 1 over 2.5 squared. And then look here at the side, 0.84. Cool. It gave me the answer already. Easy to use calculator, right? So make sure you guys use this. I'm gonna come back to my notes here. This gives me 0.84. Now here, I have minimum percentage. I have 0.84. Remember how I told you guys 0.84, this low number is probability. So for me to go from probability to percent, multiply this by 100. 0.84 times 100 is going to give me 84%. Now for your homework, I'm asking for percentage, so just give me 84. You don't have to type in percent, but just the number. Okay, so real quick, I found my mean. I saw that there was a difference. I could go down or I could go up. So the way I find my K is I find the difference divided by standard deviation. That gave me my K. So for me to use Chebyshev theorem, for me to find out what's a percentage, I'm going to go 1 minus 1 over K squared, and it gave me 84%. Now let's take a look at another example. The output from a statistical software packages indicates that the mean standard deviation of the data set consisting of 300 measurements are 1,900. That's the mean. And 500, that's the standard deviation. It says respectively. Now this 300 number, I'm going to use this as N. N is how many numbers there are. I don't really need to know how many numbers there are. I just care for the average and standard deviation. Okay? Now, what can be said about the number of measurements between 900 and 2,900? Okay. One thing really quick. I forgot to mention in the previous example. The average of these numbers, has to be the mean. Okay. You're like, how do I do the average? Remember, you add the two numbers, 900 plus 2,900 divided by 2, because you're adding two numbers, and that should give you the mean. On the previous question, we had 20 cents, 30 cents, add them up, divided by 2. That should give you the mean. That's what Chebyshev does, okay? The numbers that we're comparing has to equal to the mean. Okay, good. Now that we know that the mean, let me find my K value. Remember, for my K value, because I need K for my formula. My K value, I'm gonna go this big number because I like to deal with positives. 2,900 minus the mean divided by the standard deviation. Type this on my calculator. 2,900 minus 1,900 divided by 500 gives me 2. So the K value is going to give me 2. Good. Now that I know my K value, I'm ready to use my Chebyshev formula. Remember my Chebyshev formula was 1 minus 1 over K squared. But I know K is equal to 2. So instead of a K, let me write 2. 1 minus 1 over 2 squared. Now, if it gives me a decimal, awesome. I got this. Some of your calculators will give you a 3 over 4. The calculator doesn't know you want to deal with decimals. It thinks that you just want dealing with the fractions, so it gives you 3 over 4. Some of you might see 0.75. The same thing, right? 3 over 4, 0.75 is the same thing. Again, my calculator gave it to me as a decimal. So I'm going to change as a fraction. Change this to a decimal. Remember, fraction means divide. So I want this as a decimal. So I'm going to go 3 divided by 4. So I'm going to change this to 0.75. You want it as a decimal. But this is the probability. I'm asking for the percentage. So my percentage will be, let me write it here at the side, 75%. Because I multiply my probability times 100. take a look at another example here. The mean price of houses in a certain neighborhood is $50,000 and the standard deviation is $10,000. Find the price range for which at least 70% of the houses will sell. Some of you might be like 50,000. Yeah, I didn't want to deal with real numbers because real numbers, we were dealing with bigger quantities. I wanted to practice with small numbers. Okay. So I just have the mean in a certain, it's $50,000. All I care is that this is the mean and the standard deviation. I'm going to write my sigma is $10,000. Find a price range for which at least 70% of the houses will sell. Okay, so now here's what we have. If we had our formula, because percentage, we have our formula that 1 minus 1 over k squared is equal to 0.70. Right, 70% as a probability, as a decimal 0.70. This is what this thing is telling me. According to the Chebyshev formula, this is what we have. Okay, it would be nice if I found my k, right? If I knew what my k value is. And I'm gonna figure it out. Let me subtract the 1 from each side. Let me subtract 1, so this cancels out. So I have a negative over 1k squared is equal to negative 0.3. If I multiply both sides by negative 1, basically the negatives cancel out, right? Now I want the side to be a fraction. So let me just write this as a 1. 0.3 is a 1. Some of you might see, can I write that as 3 over 10? It's fine. The only thing is that I'm going to flip my fraction. I'm going to do the reciprocals on each side. So I have k squared over 1. It's equal to 1 over 0.3. So that means that k squared, because I'm going to get a decimal, 1 divided by 0.3 is like a bunch of 3s, right? If I do the square root of that, that gives me my k, and my k is going to be about 1.83. Okay. Yeah, about 1.83. Not bad. You're like, oh my God, Mr. Leonzo, how did you do that? Okay, let me show you. Let me come back to my calculator here. Let me clear this out. Had a square root, right? Didn't at the beginning and the inside, I had a fraction. And then wasn't my fraction 1 divided by 0.3? So 1 divided by 0.3. And then you guys see 1.83. I rounded it to 1.83. Good. So I have my K value. But now here it's asking find the price range. Price range. Okay, so for my price range, what I'm going to do, I'm gonna go the mean plus or minus my K value times my standard deviation. So for my mean, I know it's 50,000 plus or minus 1.83, and I know my standard deviation is 10,000. So for my first value, I'm going to go 50,000 minus 1.83 times 10,000, and that's going to give me 31,700. For my second value, I'm going to go 50,000 plus 1.83 times 10,000, and that's going to give me 68,300. So if I'm in a neighborhood where the houses are selling about 50%, and the standard is 10,000. I mean, the houses are selling for about $50,000. That's the mean. And the standard deviation is about $10,000. 70% of the houses, so 70% of the houses that are being sold are going to be in between 31,700 and 68,300. 70% of the houses will be in that range. Good. Let's take a look at here. A survey tracks a nationally representative sample of students from 8th grade through high school and college. Research published in a journal examined the scores of 265 students who paid a private tutor to help them improve their scores. The table below summarizes the changes in both mathematics and verbal scores for these students. So we have a mean in math and verbal. We have a standard deviation score in math and in verbal. Those are the changes. So we have a mean and we have a standard deviation in math and verbal. So here, suppose one of the 265 students who paid a private tutor selected at random. Give the interval that is likely to contain the student's math scores. So my mean is 24, standard deviation 65. That is the interval that contains 8/9 of the changes in students' math scores. Okay, so remember, I need to find my K value. What this thing is telling me is that 1 minus 1 over K squared, it's equal to 8/9. So I need to figure out what's my K. Let's see. Let me subtract the 1. But my 1, because I'm dealing with fractions, I remember when I'm dealing with fractions, I can write my 1 as a common denominator. So I have the negative 1 over K squared. It's equal to negative 1/9. The negatives cancel out, right? Oh, cool. So I flip my fractions. For space purposes, let me say K squared over 1 is equal to 9/1. So I have that K squared is equal to 9. I think from here we can see that K is equal to 3, right? Cool. I have my K value. K value is 3. So now here, I need to type in my interval. So information that I have, K is equal to 3. My average is 24. My standard deviation is 65. So for my interval, remember I have to go average plus or minus K times standard deviation. So for my first number, I'm going to go 24 minus 3 times 65. And it gives me a negative 171. For the second number, I'm going to go 24 plus 3 times standard deviation, and my calculator gives me 219. Nice. Okay, so what does this mean? 8/9. 8/9 is a big, big number, right? 8/9 of the students will be in between negative 171 and positive 219. That's going to be their scores. Good. Chevy Chef rule, that's what you guys are going to be using. Make sure you guys learn how to find your K. Am I asking for probability? Am I asking for percentage? Remember, probability is given as a decimal between 0 and 1. If I'm asking for percentage, it's a number between 0 and 100. So make sure you understand what I'm asking.